products. Really easy idea. Like I said, it's multiplying again. Same thing we did in 9-2. But with special products, the problems are a little bit different. But not much. How do we do that? Distributive property. It's the same thing. We're distributing x plus 3 to itself. It's the factors happen to be the same. So it's x plus 3 times x plus 3. So I'm doing it with the distributive property here. And x squared plus 3x. Then distribute the 3 is 3x plus 9. So combine like terms at the end. X squared plus 6x plus 9. What's special about it is the fact that the factors are the same. The two binomials that we're multiplying together are exactly the same. Okay. What that's another way of writing that would be if they did something like this: x plus 4 and then wrote squared on the outside. That's how they're normally going to write them. But what does that mean? What does it mean to square something? Multiply it times itself, right? Just twice. X plus 4 times x plus 4. So since we know that that's what it is, that's what we're going to do. We're going to multiply x plus 4 times itself. And maybe after we've done this a couple of times, or a few times, we'll start recognizing maybe a few shortcuts that we might be able to take as we go. So that's going to be x squared plus 4x plus 4x plus 16, right? So combine like terms. 4x and 4x is 8x in the middle. 16 on the end. And there's the trinomial we got as an answer. Do we see anything pattern-wise picking up here? What's going on? What do you mean? Which part? So like when you square x plus 4, what happens to the front piece? What changes about it? What gets the 16? 4 times 4, right? Which is actually 4 to what power? Second squared, right? Same as this squared. So if we square x, we get this thing in front. If we square 4, we get this thing in the back. How can we get the middle piece? Say it again, boy. All right. So when we combine those like terms on both of these examples, up here we had 3x and 3x. From the original binomial was x plus 3. Double 3x's. Here the original binomial had x plus 4. We had 4x and 4x. All right, so there's how many of them? You double it, multiply it by 2. So the shortcut that you could maybe think of here is square the front, square the back, put them together, and double it. That can get you there a little quicker. Working it out this way is the long way of doing it, and it works every time. It'll work just like what we've been doing. But there's some shortcuts when there's special products like this. So like, let's try that on this one, x plus 5 squared. So the kind of the shortcut we're looking at here is to get the front piece, we square the front. So square x. That's x squared, right? The back piece is going to be square the 5, which would be how much? Well, there'll be a 10x in the middle. What's the third term? 25, and it's always a plus there. And in the middle, put them together. 5x times 2 is 10x, and that's where Adam's getting at. So we got a shortcut that we can use when we're squaring a binomial like that. And it turns into a trinomial. There aren't any shortcuts with trinomials. Binomials are only, but here's the great thing. We're not going to do a lot of trinomials. You square a lot of binomials in algebra, in high school algebra. You don't usually trinomials, you don't end up squaring them very much. So there's not any shortcuts for them, or not any really obvious shortcuts for those. But there are shortcuts for these binomials. Let's try this one, x minus 3. So this is a lot like example A, but it's a minus sign instead of a plus sign. Okay, so let's try that shortcut stuff again. What's the first piece? X squared, right? We square whatever's in front. When we square x, it's x squared. The middle piece, put them together and double it. So what's that going to be? Negative 6x. Good job. Negative 6x. And then the last piece is square what's in the back. When I square negative 3, what's negative 3 times negative 3? Positive 9. And we've taken care of that shortcut and multiplied that binomial out. That squaring of a binomial. What these trinomials are called, they're called perfect square trinomials because they came from this, came from something squared. That's why they're called perfect squares. Let's get another one here. I think y'all are starting to catch that shortcut. Let's do x minus 4. Same, lot like example B, but a minus sign. What's the first piece? X squared. Then what? Minus 8x plus 16. Good job. That's it. So if we did, what if I did x plus 9 squared? Good job. See how quick, just knowing your multiplication tables, and, it's a really quick shortcut kind of idea. Let's do one more of those. X minus, we'll get the multiplication tables nobody knows. 11s. So it'll be x squared minus 22x 121, yeah. Oh, that 11 times 2 is still not 12. Yeah. So minus in the middle of your binomial, minus in the middle of your trinomial. So that sign stays the same in the middle. Notice every one of these, no matter what the sign in the middle was, the last term always had what in front of it? Positive. Because you're squaring something. That's the reason it's always going to turn positive on the end there. Let's go to a little bit more difficult one. Maybe there's a number with that first term instead of just plain x. Maybe it's like 2x plus 7. But the pattern stays the same. So the first piece is squaring this. When you square 2x, what does it become? 4x squared. Because you're squaring the whole thing. You're saying 2x times itself. 2x times 2x is 4x squared. Now the middle piece, we had 11 and x, and we doubled it. That'd be 11x times 2. Here, 7 times 2x would be 14x, and then we got to double that. 28x. And it's a plus because there's a plus in the middle of that. 8 didn't turn out good. Let's fix that. And then the last term would be 7 squared, which is 49. So even when there's a number there, you can take that shortcut for these. We'll do several more of those. Let's say we had 3x plus 5 squared. What's the first term? Try again. 9. Square 3. Not 3 times 2, but square it. It'd be 9x squared. The middle term is, 5 times 3 is 15. And then double that to 30x plus 25. I don't know. Maybe let's try this one. 7x minus 8. Put a minus sign in there. So we gotta be careful. What's in the front? 49x squared. What's in the middle? 102? No.
756.
Double 56 would be 112. Is it a plus or a minus? Minus 112 x plus how much? 64. Let's do 12x minus 5 squared. What's the first term? 144. Yeah, 144x squared. Good job. Middle term. 60, double it. 120, positive or negative? 12 times 5. So we're always going to multiply those two together and then double it for the middle term. That's what we're doing. That's how we've been getting that middle term. So 60, negative 60, and double it's negative 120. Exactly. If you know your multiplication tables, this is the easiest thing to do.
So what do we get from 12 times 5? We times it by 2.
To get the middle piece, that's right. What goes on the end? Plus 25. Close. Really, I don't get much harder than that on that particular special. We're about to look at a different special product, but I think it's even easier to make because the answers are shorter, believe it or not. So let's go. Let's look at a different problem. Let's say we had x plus 5 times x minus 5. It almost looks the same, but they're different. One's a plus and one's a minus. If we do this the long way, let's see what happens. So I want to distribute x plus 5 to both of those. Be x times x plus 5 minus 5 times x plus 5. So that's going to be x squared plus 5x minus 5x minus 25. And then what do we do next? We got like terms here in the middle. What happens to them? They cancel each other out. One's a plus 5x, one's a minus 5x, so they're gone. And you got x squared minus 25. It does look like Christmas, it does. You got a while to wait for Christmas. Hey, I'm sorry. You got a long time. You got a lot of work to do to get on the good list. I wish we could sometimes, but not all the time. So let's say we had x plus 6, x minus 6.
Is there a way to do the shortcut?
I'm waiting for you to tell me. I'm not going to tell you. I'm waiting for you to tell me. Why? And then what happens to the stuff in the middle? They cancel out. Yeah, so x squared minus 36. So that's why I say this one's easier. Because you got to look for it, make sure they match, and except for the plus and the minus. If they don't match, you got to do it the other way. Okay, you got to do it like we did yesterday.
So you can't so if it's this way and it's not the same numbers, you can cancel those.
The middle part doesn't cancel out. You got to do it with the distributive property.
Let's do one like that.
Let's get one more with this shortcut, just make sure we know it. All right. Let's say we had x minus 8. Bless you. I was waiting for you to get all 5 of them in there. So here's that shortcut. In different order this time. I put the minus in front, but that doesn't matter. X squared minus 64. Pretty easy. Now, what if we put a number in the front there with like a 2x plus 5 and a 2x minus 5? They still match, right? Except for the plus and minus. So that means that shortcut still should work. What's the front piece?
4x squared.
Yeah, 4x squared minus 25. Doesn't make it any harder. You just say 2x times 2x, that's the front. 5 times 5, that's the back. It's minus in the middle. What this is called is a difference of squares. Because you got this from squaring the front piece, you got this from squaring the back piece, and the minus sign, that's math. The difference is minus in math. So let's say you had 3x minus 7, 3x plus 7. 3x times 3x is 9x squared. 7 times 7 is 49, minus in the middle. This shortcut is easier than the other one. There's less to do, right? Can you do the shortcut with this one? Why not? The x it's not the same. So you've got to be able to recognize that as we go. You're going to get in this, kind of rock to sleep here. It's the same thing over and over, and then they're going to throw one in here and say, multiply. But you can't use shortcut because they don't match perfectly. Almost, got the plus and the minus 9, but the front's not the same. So we got to do this one the way we did in 9-2, this distributive property. So that'd be, I'm going to write it out. Be minus 9, and then 4x plus 9. And then distribute. 12x squared plus 27x minus 36x minus 81. Try again. Nine x. 27, 36 are 9 apart. And then minus 81. I don't do 4. Because it only works for binomial times binomial. It doesn't work for anything else. So I just do distributive property. That is FOIL. That's what that is. It's the same order. Everything's the same. I just don't say FOIL. I just say distributive property. I used to do FOIL, but I don't do it anymore. I hadn't taught it in several years. All right. Let's do one more. There's no other shortcuts that we're going to learn in this particular class. There's some that we'll talk about when you get to Algebra 2. What if they flip it around like that? Put the number in the front and the x in the back. Okay, so what's the answer then? No. Not negative 100, but 10 times 10 is going to be positive 100. And then you're right on the minus x squared. So you just got to be careful what order are they putting the factors in, and then you can rearrange and go from there. Now, I know that's not descending order, but the idea is here, the shortcut's what we're at. I would prefer it. Technically, yes. That would be the descending order version of that, yes. Not bad today, right? So it's pretty easy Friday, right? So
when you do the abbreviation for B, put BG.
why?
Because when you think about it.
How about I write it out? Page.
Yeah.
I'll even write out 500.
Okay.
I'm not going to do that. Page 572. 3 through 34. Yeah. It's 31. 32 problems, excuse me. There's a shortcut on every one of them.
So we all have to do that distributive property.
Shouldn't.
Okay, you can leave it up there.
All right. We got a few minutes till lunch here.
I think my pencil dropped some money.